found the 5-number summary previously. So last time we did our 5-number summary for this data set. So we had 6.5, 12, 13.6, 14.4, and 14 for our 5-number summary. So when we're doing our box plot, the step 1 is to figure out your upper and lower fences. That's going to be based on these 3 formulas here. And remember on the test, I'll give you the formula for the fences, but I won't give you the one for the interquartile range. You have to know that one. So for this one to start off, when we do our interquartile range for this example, for this one, our interquartile range, actually we found that before, did we, for this one? No, I think we just found that. Okay. So, remember this is our minimum, this is our Q1, this is our median, this is our Q3, and this is our maximum. So when we find the interquartile range, it has to be Q3 minus Q1, so it would be 14.4 minus 12, and we get 2.4 for our interquartile range for this one. And so once we have that value, we can go ahead and figure out what our fences are. We do the lower fence first. That's going to be Q1 minus 1.5 times your IQR. So 12 minus 1.5 times 2.4. 8.4 maybe? Double check. Alright, so there's our lower fence. We also have an upper fence, that's Q3 plus 1.5 times our IQR. So that's 14.4 plus 1.5 times 2.4, so that's 3.6, or I think that might be 18. Okay, those are my fences when I draw this box plot. So anything between 8.4 and 18 are going to be okay. So these are our numbers up here. I went ahead and put them into numerical order rather than random like they are in the notes. So looking at your list, do we have any outliers for this one? I think which one is an outlier? So this one here is going to be an outlier. Now that we have that established, we're going to go ahead and just do our box plot. So we'll start with a number line, make sure it covers 6.5 all the way up to 14.5. Number line. 6, 7, 8, 9. When you do this on the test, you'll want to be sure you label your number line. Here, don't just draw the basic shape that you see on your TI-84, because I need to know what those numbers represent. So you have to be sure to put in your numbers
when you draw your number line, otherwise I'm going to take off because I don't have any point of reference for what your numbers are. So we'll start with the boxes in the middle because those are the easiest ones. So we'll draw vertical lines at our three quartiles here. So at 12 we get a vertical line, at 13.6 right there, at 14.4 there. So I've got my three vertical lines and I'm just going to enclose them in a box like that, and that's the box part of my box and whiskers. Now I have to do the whiskers. I'm actually going to start with the upper whisker because it's easier to do. My upper whisker is 14.5, which is actually really close to that one. So from 14.4 to 14.5, those are going to be really close. So I'm just going to draw a very short horizontal line, and that's a really, really short whisker for that one. So on the other side, on the left-hand side, that one's the hard one because I do have an outlier. So my lower fence is 8.4. So I've got 8.4. Would be right about that. So that would be where my fence is. My upper fence is 18, but that's way off the grid, so I didn't include that one. But 8.4 is right here. That's my fence. My whisker can't go past my fence. It can't go all the way over here to 6.5. So I have to determine how far out my whisker is going to go. I don't want it just to go all the way to the fence. I want it to go to the, let's see, how do I word it? They word it kind of funny. The smallest data value that is larger than the lower fence. So basically the smallest data value that is not an outlier is basically what I'm looking at. So over here, here's my set of numbers. Here's my smallest number, but I can't go all the way to 6.5 because that's on the other side of the fence, and so I can't go there. So if I look at the next smallest number, 9.9, that's the number I'm going to use. So when I draw out my whisker, I'm going to go to this number here, the smallest number that's listed that's not an outlier. So I'm going to draw my line. 9.9 is about right here. So I'm going to draw, this number here is 9.9. Smallest number that is not an outlier. All right, so we don't want to go to 6.5 because we can't go past the fence. We don't want to go all the way to the fence every single time. We want to look to see what the smallest number is that's not an outlier. So that 9.9 is going to be more like a modified minimum. If we take out the outliers, 9.9 is the smallest number in our data set. So don't go all the way to the fence, don't go past the fence, just go to the smallest number in your data set that's not an outlier. And then the last thing we want to do is we still want to acknowledge that the that outlier is part of our data set. So over here at 6.5, we'll just draw a little asterisk. That part is just going to be an outlier. And you don't have to label these things when you do your test. All I need is the number line with the units on there, the box and the whiskers, and this star right here. You don't have to say this is an outlier. You don't have to say this is 9.9. I'll be able to tell where your 9.9 is. That's just so when you go through and you look at your notes, you wonder why I stopped right here and didn't go all the way out. So that's the only reason I wrote that up there. You don't have to write that on the test.
What is the small whisker number?
What is the what?
The small whisker, what's the number for that one?
Say it one more time.
The small whisker, what's the number for that one?
This one?
No, the other one.
Oh, the upper whisker?
Yes, ma'am.
Oh, sorry, that's a 14.5. That's our largest number that we have right here.
Gotcha.
Thank you. So I guess I can label all these. This is our Q1, this is our median, this is our Q3, and then this number right here that's kind of hard to see, that's our maximum, which is 14.5. But those two, since they're so close together, it's hard to really tell what that upper whisker looks like. We'll come back to this example. I'll run through and do it on the TI-84 in a minute so you can see what it looks